Hello everyone, welcome back to the channel. So in the series of solving the DSA problems, I have been teaching the sorting techniques. The previous video I had explained about the selection sort, and in this video I'll be explaining the the merge sort, the bubble sort, and the quick sort. I will be explaining in the next videos. So without any delay, let's get back to our board and let's analyze what is this merge sort and how can we merge this. Guys, you can see on your screen I have taken an example of the array. So this array is not sorted, this is in the unsorted order. So how to sort this array using merge sort? Guys, it is simple, easy, and yeah, so all the sorting techniques you guys should know because it might come in an interview, like the interviewer might ask you any of the sorting techniques and you have to be ready with all the sorting techniques. That's one of the most important fundamentals of solving any of the problems. So let's sort this array. I'll be dry running this merge sort. I'll be visually showing you how this dry run happens. So first I'll show you the dry run. Second, I'll show you the pseudocode, and third I'll show you the actual code. I'll implement the code and I'll show you. In the last step, I will show you how the recursion will happen in this merge sort. So let's go and let's solve this. Guys, you can see over here this I have taken total 8 different elements. So the index will start from 0 and it will end at 7. First I'll calculate the mid. So the mid would be low plus high by 2. So here the mid is 0. 0 plus 7 by 2. This would be 3. So I will be splitting the array. Like I'll be splitting the array from 0 to 3. And from 3 plus 1, that is 4. I'll be splitting from 4 to 7. Like this. I'll split this much and I'll split this much. From 0 to mid, I'll split it as one array, and from 4 to 7, I'll split it as the second array. So let's do this. Okay, so now I'll split this array. I'll split this array into 8, 3, 1 and 2. I splitted this array, and here I'll split this into 1, 5, 4 and 2. Let's split this 1, 5, 4 and 2. So here the indices are 0, 1, 2 and 3, and here the indices are 4, 5, 6 and 7. So again I'll do the same thing for this array and this array. Here I'll do 0 plus mid by 2, that is low plus mid by 2. Initially this is low and this is high. Initially this would be low and this would be high. I'll do 0 plus 7 by 2 and I'll get 3. I'll split this into 0 to 3 and 4 to 7. And here again I'll do 0 plus 3 by 2. I would end up with 1 as the mid, and again I'll split 0, 1 and 2, 3. Here again I would do 4 plus 7. I would get 5, and here I would do 4 and 5, 6 and 7 as the separate arrays. Here I'll split this into 8 and 3. And here I'll split this into 1 and 2. Here I'll split this into, is this 1 or 7? I'm sorry guys, this is 7. This is 7. And here I'll split this into 1 and 5. And here I'll split this into 4 and 2. Guys, don't worry how is this splitting happening. I will show you when I'll explain the recursion, how the recursion call is happening over here. So basically we are just splitting this arrays, and we are splitting in such a manner that we are recursively calling the array, and we will split this array into 2 halves. N by, first I'll split this array into n by 2, then I'll split it into n by 4, then n by 8 and so on. And here again I will have the indexes 0 and 1, here 2 and 3, here 4 and 5, here 6 and 7. Again I'll add 0 and 1, I'll do 1 by 2, I'll get 0, I'll split this into 8 and 3. So these are the individual elements of the array. Here I'll split this into 7 and 2, here I'll split this into 1 and 5, here I'll split this into 4 and 2 separately. So this is how the splitting is happening. And after I split this, whenever I come up with the one element, here you can see this is one element, one element, one element. Whenever I land at a point where I have only one element, then no further divisions is possible. When no further division is possible, then at that case what I'll do, I'll just merge this arrays into uh, I just merge these arrays. I just merge this every single elements. Like I'll merge this 8 and 3 into 3 and 8, and I'll merge this into 7 and 2 into 2 and 7 in such a manner that I'll merge this in such a way that it will be in a sorted order. So I'll write a merge function that will merge the two individual elements into the single array, and this would be in a sorted order. I'll merge in such a way that I'll merge this two individual elements into single array in such a manner that this array is in this splitted arrays will be in a sorted order. Here I'll merge this 1 and 5, and here I'll merge this as 2 and 4. Now you can see I have merged all this into the single elements, and all this are the sorted arrays. Again, I'll merge this 3 and 8. I'll merge this array and this array. This would give me 2, 3, 7, and 8. Again, I'll merge this into 1, 2, 4, and 5. I have written a merge function which merges these two arrays into the single array in a sorted order. And again, I'll merge this into the single array like this. So first I'll take 1, next 2, 3, 4, 5, 7, and at the last 8. So you can see all the elements have been sorted. I'm sorry guys, I think I have missed one element, that is 2. 2, and here I'll be having 3. Yeah. 1, 2, 2, 3, 4, 5, 7, 8, and 8. So you can see all the elements in the array are in the ascending order, that is all the elements are in a sorted fashion. So this is the technique of how the merge sort will split the arrays. First step you can see here, first we split, split, split. Whenever we land with all the elements which are single, that is here the 8 is only one element, 3, 7, 2. Whenever we land with only one element, then we cannot further divide the array, and at that step we will stop our recursion call. We will stop our recursion call, and we will merge the arrays into the we'll merge these elements into the single array in a sorted fashion. So in this way, we can see the array is sorted, and first we first we divide, and then we merge. In this way, this technique is also called as divide and conquer technique. First this merge sort, quick sort will come in the technique of divide and conquer. First we divide and then we conquer. So this way we can merge this. So this was the dry run and this was the technique. Now first I'll directly code this. You may not understand the code. If you understand, then very well. After coding, I will just dry run whatever I have done. So first I'll write the code. Why? Because you people may not understand this code. No problem, it's okay if you don't understand, no worries. But after implementing this code, I'll be explaining each and every line in my code. Okay, so first I'll take an array. What I'll do is I'll just take an array. 1 second. Okay, I'll just take the user input elements. System dot out dot println, enter the number of elements. First I'll take the input as enter the number of elements, and here I'll take a scanner class. Scanner input equal to new scanner system dot in. Here I've taken scanner, and here I'll take n as the input from the user, input dot next end. Here I have taken the input. Yeah, and this is over. I think I have done a mistake over here in taking the scanner class. Okay. Oh shit. Sorry guys, this is time. Okay, done. Okay. Now I'll take the for loop and I'll take the array elements as the input from the user. So here I'm taking the input from the user. So I think I have not declared the array. I'll declare the array over here. I make a lot of mistake while writing the code. Shit. Okay. Here I'll take the input from the user. I'll just define the array over here. Int arr equal to new int, and I'll take this as n. Size, and here I'll take the array elements as input. Here, yeah, okay. Dot next in. So here I have taken all the elements input from the user. Here I'll write just a one line, that is enter the array elements. Enter the elements of the array. Here I have taken the user input. So here I'll be taking the array elements as input. Up till here, this is just a basic, nothing much complex in this code. Just you are initializing the array and you are taking the input from the user. After doing the step, the actual merge sort will start from here. So here I'll be calling the function merge sort, and in this merge sort I will be passing the array, okay, and I'll be passing the indexes of the array. One is 0 and the second one is 0 is the low and high is the length of the array, that is n. I think I'll take n minus 1. Yeah, size minus 1. So here I'll be writing all the function definitions, the merge sort function definition. Here I'll write the definition, public static void, and this is merge sort, and here I'll take the array, and here I'll take the low, and here I'll take the high, and yeah, this one done. And here I'll be writing the function definition of merge sort. Guys, this merge sort function I will be calling recursively. I will be calling recursively such that it splits and merge. Split and merge. That is the technique. And when I will stop my splitting is whenever I reach at a point where I get a single element. At that point, I will stop the splitting. I will stop the dividing at that point whenever I reach at the stage where only single element is left. So for that, I will write a base case. The base case is whenever I have low and high pointing at the same index, then stop my recursion. Instead of giving low is equal to high, I can give low is greater than high. This doesn't make any difference. And whenever my low and high is pointing to the single element, at that point, whenever low and high have the same index, at that point I will stop my dividing and I'll start my merging. And here I'll write the recursive call. If you don't understand this recursive call, no worries, nothing to worry. I'll explain this, the recursion tree, each and every step of the recursion in the in next few minutes. And here I will be taking the array and the low. I'll give it as, instead of giving this, first I'll just take the mid. I did not calculate the mid over here. Mid will be low plus high by 2. So this is the mid. This will divide, and in place of low I'll be splitting. In place of low I'll give it as low, and high I'll give it as mid. And here I'll take the merge sort, and here I'll pass the array, and here I'll the next half of the array which I'll be splitting. The first left part of the array is this. This is the left part of the array, this one, and this is the right part of the array which I will be splitting from mid plus 1 till high. And here I'll just write the code that will merge the splitted arrays into single array in a sorted fashion. For this, I'll be passing ARR, that is the array. I'll be passing the low, I'll be passing the mid, and I'll be passing the high. So, guys, this is this 1, 2, 3, 4, 5. This 5 lines will do the trick for recursion. Will do the step of merging. Will do the steps for dividing and merging. So this is completely the recursion, guys. These 5 lines which I have written is completely recursion. So don't worry if you did not understand this part of code. I will be explaining this merge sort definition. I will be explaining this in few minutes. Here I'll be writing the code which merges the divided arrays. For this, public static void the return type and the merge. Here I'll be taking the parameters as one is array, one is low, one would be the mid, and another one would be the high. So in this way I will just take this and I'll take in guys, I'll take 2 pointers. One is left pointer and another one is the right pointer. So how is the merging happening? If you don't understand, no problem. First I'll take the I'll explain this part also in the next few minutes. So if you don't understand, it's totally fine. You just watch this code. Here the left pointer will be pointing to the low, and the right pointer, RIGHT, the right pointer would be pointing to mid plus 1. If you don't understand, wait, I'll just show here. Guys, after splitting this, here you can see at this step how the merge is happening is, if this is the 2378, sorry guys, 1 second, 2, 3, 7 and 8. If this is the merged array, and if this is 1, 2, 4 and 5, and this is the merged array, and now I have to merge this into the single array. For this I will take the left pointer which would be pointing to the low, and this is the right pointer which would be pointing to mid plus 1. So initially this would be my mid, so my right would be pointing to mid plus 1th element, and the low would be pointing to the 0th element. So how the merge is happening is, I will explain this here itself. I'll take the total array, I'll take the temporary array over here so that I can add all these elements. Guys, here how the merge is happening is, imagine this as the left index, this is the right index. So first I'll compare the right element value and the left element value and the right element value. You can see the right element value is less than the left element value, so I will add this in 1, and I'll move right to the next index. I'm sorry guys, here I'll just take this right to the next index, and here again we will compare the right index value and the left index value, 2 and 2. Here both the elements are equal, so I'll just take any one of them. I'll take the left element value and I'll move this left pointer to the next index. Here again the right and the left index elements would be compared, 3 and 2. So the minimum element from the left index and the right element would be we would put that element in the temporary array, and here we would compare 3 and 2. You can see 2 is smaller, so I'll put 2 over here and I'll move the right index to the next element. And here you can see the left and the right index, that is 3 and 4. Comparing 3 and 4, 3 is minimum, so I'll add 3 and I'll move my left index to the next step. Here you can see 7 and 4. Which one is minimum? 4 is minimum, so I'll add 4 and I'll move right to the next index. So this is my right. Again, I'll compare 7 and 5. You can see 5 is minimum, so I will add 5. So again, I'll move right to the next index. So here you can see the right is at the dead end. The right is at the dead end. Right is at the dead end. You cannot further move the right because this array, the second array, is exhausted. This is exhausted. So whenever the right part of the array or the left part of the array is exhausted, at that case you just add all the elements from the left array or the right array. Here the right array is exhausted, so I'll just add all the elements from the left array. So without any comparison, I'll just add these elements. So here I have been left with 7 and 8. I'll just add this 7 and 8 directly. If the left array was exhausted, I would add the right array elements into the final result array. If the right array is exhausted, I'll just add all the remaining elements from the left array back to the result array. So this is the result array. Guys, in this way you have to merge. So for this, I'll write the code now. Now you can see whatever I have explained, I'll just write now. So this part, that is the merge sort definition, I'll explain this in the next few minutes, but this merge I have explained now. So for this, I'll be writing the code. Left is low, right is mid plus 1. And here I'll be writing the code. 1 second. Yeah, I'll be writing the code while left is less than or equal to mid and right is less than or equal to high. Till then, what you do is you just compare this. Why did I write this condition? Left is less than or equal to mid, right is less than or equal to high. I will be moving this. You can see over here. So if this is initially left is pointing here, right is pointing here. So the size of this array is mid. Mid is the length of this array, and the total height is the length of this right array. So because of that, in order to move left till the mid and in order to move right till the high, I have taken the boundaries as mid and high. So I have taken the boundaries as mid and high, and here I'll be comparing if the left part of the element is less than or equal to mid. If the left part of the array is less than the right part, at this case, if the left value is less than the right value, I'll add this in a temporary array. So I'll create a temporary array over here in temp. I'm sorry, I think I have done the wrong declaration over here. And here I will be doing the size of this temp would be till I'll take it as high minus low plus 1. So this would be the size of the temp, and in this temp array I'll be adding the 1 minute. I'll take one more element, that is k. I'll take int k as 0, and here if the left value is less than the right value, then just add the left value inside this and move the left to the next index. And move the left to the next index and add this over here. And here I'll take f. No need of else if, I can directly take else. Else part tells us that if the right element is greater than, if the right element is less than the left element, then just add the right element into the temporary array. That is temp of k plus plus equal to ARR of right plus plus. Guys, here what I did is, if the left element is less than the right element, just add that into the temporary array and move the left to the next index. And here if the right element is less than the left element, just add that right element into the temporary array and move the right to the next index that I had explained in the that I have explained previously before. I have explained the dry run of how to merge this. After merging, the next condition that I will be writing is the exhausted condition, whether the left array is exhausted or the right array is exhausted. If the left array is exhausted, then add all the elements of the right array elements into the temporary array. If the left array is exhausted, then add all the right elements. If the right array is exhausted, add all the left elements. For this, uh, while left is less than or equal to mid. This tells that right array is exhausted, still the left array elements are still remaining. At this case, you just add temp of k plus plus. You just add the value. In second, yeah, arr of left plus plus. If the right array is exhausted, and here if the left array is exhausted, if right is less than or equal to high, at this case you just add this and you just add this in the temporary array. After doing this much, all the merged array is in the temp. I need this in my original array. For this, I have to add all this in my array. For this, I'll take a for loop for int I equal to 0. This was a temporary array, but I have to add this in my permanent array, that is arr. I have to add all these elements from temp to arr. For this, I take the k as the maximum, that is the length of that temporary array. Why? Because k would have moved till the end of the temporary array. And here I take I plus plus, and over here I just add these elements, that is low plus I, and here I'll be adding temp of I. So here all the elements from the temp would be added to the array of the particular index, the actual position of that element in the sorted array. So yeah, I think we have pretty much coded the code for the merge sort. I think this code is perfectly right. Yeah, and okay, that's all I guess. And here I'll be printing the array which I have sorted. I plus plus, and here I'll be printing print of arr of I, and I'll give a space so that it looks good in the output. Yeah, I guess the code works proper. There is no error in the code. Let's run this once and let's see whether the code is perfectly working right, or is there is any problem. Okay, everything is right. Let's run this once and let's see for the output. It's asking me enter the number of elements. I'll take the count of the elements as something 8. Enter the elements of the array. I'll just enter the unsorted elements 8, 2, 3, 5, 1, and I'll take 9, and I'll take 7, and I'll take out of 0 I'll take, I think this is unsorted. Guys, you can see on the screen over here the elements of the array are sorted 1 2 3 4 5 7 8 9. Yeah, so the elements are sorted in a perfect order. You can see the code on the screen. You can see the code. This is the code for merge sort. This is the recursive code for the merge sort. So this is the merge. This is the function for merge. Okay, so yeah, now let's look at the recursion calls, how the recursion calls are taking place. I'll just take the screenshot of this and I'll just add it in my board. Here I have taken the screenshot of this. Okay, and here I'll go to my board and I'll just show you the dry run of how the merge sort is taking place. Here I'll just paste the uh, code that I have written and I'll explain this over here. Guys, you can see this is the code that I wanted to explain. This is the recursive calls. What is a recursion? What is the recursive function? The function that calls itself again and again till some base condition is reached. Till some base condition is reached, the function which calls itself again and again, that is nothing but the recursion. That is nothing but the recursive function. So this merge sort is a recursive function. So for this, I'll be writing the code. For this, I'll be taking the example of a small array that is 3 second, guys. I'll just enhance this. Okay, 3. I'll write this 3, 2, 4, 1, and 3. So this is the array that I have taken, and I will show you the recursive calls, how the recursion is happening over here. So this is 0, 1, 2, 3, 4. So guys, in the first step, it will check if low is equal to high. So initially the low would be pointing here, high would be pointing here. No, the low is not equal to high. So at this case, it will calculate the mid. Here the mid is 4 plus 0 by 2. 4 plus 0 by 2. This would give me 2. So the array would be splitted as 0, 1, 2 and 3, 4. So here I'll be writing the merge sort code. Merge sort of array low and high, and here mid would be calculated, and this would be I'm sorry, here, okay, here the merge sort of the array, the low is 0, the high is 2, merge sort of ARR of, and here I'll be taking the low as mid plus 1, that is 3, and till the high 4. Here I have written the merge function. So let's only discuss about the recursion, how the recursion is taking place. Here merge sort of ARR of 0, 2. Here this function would call itself, and this would call one more function, that is the same merge sort function. For this merge sort function, the low is 0 and the high is 2. And here again one more merge sort. This would be array, and the low is 0. The mid would be 0 plus 2 by 2. So 2 by 2 is 1. So the low would be 0 and the mid would be 1. And here the merge sort of ARR of 1 plus 1, that is 2, 2. So this is the second step of merge sort. And here this recursion merge sort function will call one more merge sort of ARR of 0, 1. And here the mid would be calculated again, that would be 0 plus 1 by 2. It would give me 0, and it would be a merge sort of ARR of low, and high would be 0 plus 1 by 2, that would be 0. And here the merge sort would be ARR of high, that is mid plus 1, that is 0 plus 1, 1 and 1. And in the fourth step, again one more recursion would be called, that is merge sort of ARR of 0, 0. And in this step, the base case that I have written, that is low is equal to high, would be checked, and here 0 is equal to 0. At this step, I'll return back to the previous merge sort which I have called, and here this would be back here. The function call would return in this step, and here again the merge sort would be called, that would be merge sort of ARR of 1, 1. Here you can see again this base case 1 is equal to 1. So at this case I will come over here, that is merge. So this is the function that I have written over here, So the function call would come over here at this step where the array will merge. The array will merge the individual elements. Array would merge into the individual elements and the individual elements would be sorted. This sorted technique I have explained in the selection sort as well. And yeah, here the elements would be merged and the function call would go over here again, and this merge sort will again call one more merge sort, that is merge sort of arr of 2 comma 2. Here 2 is equal to 2. So at this case the function call would return back over here to the merge function, and here the individual elements, that is the two different arrays, would be merged into the single array in a sorted order. And here again the function, the function call would come over here, and this function call would be called, and here again one more merge sort would be called arr of 3 comma 4, and here again I will be having mid plus 4 plus 3 by 2, that is 7 by 2, that is 3. So merge sort of arr of low is 3 and mid is 3 plus 4 by 2, that is 7 by 2, that is 3. And here one more merge sort would be called, that is merge sort of mid plus 1, that is 3 plus 1 is 4 comma 4. So this would internally call one more merge sort, this would internally call one more merge sort. Here 3 is equal to 3 and here 4 is equal to 4. Here the base cases would be reached and the merge function would be called, and this array elements would be merged. Guys, in this way the merging is happening, and this is the code for this. Here you can see the merge sort and merge. First this would take place, then this would, and then at the last this would take place. This would be the merge function, which will be internally merging the two sorted arrays into the single array. So this merge function is doing this step, and merge sort would be recursively called, and whenever the base case is reached, it would eternally stop the recursion. And it will give the that is the control to the merge. The control would go to the merge function. In this way the merge sort is happening. So let's analyze the time complexity of this merge sort. How is the time complexity calculated for this merge sort? So for calculating the time complexity of the merge sort, I'm sorry, here I think it's unnecessary. Okay, let's analyze the time complexity. One second, I'm sorry. Here I'll just write the time complexity, TO. Guys, you can see first the size of the elements would be n, and then I would split this into n by 2 and n by 2, and then again I would split this into n by 4 and n by 4. Here again I will split this into n by 4 into n by 4. In this way I will be splitting the elements. So whenever I split the elements, the time complexity for that would be O of log base to n. This would be the time complexity for dividing the array. Guys, one more important thing that I forgot to tell us, this merge sort would come in the concept called divide and conquer, that is divide and merge. First we divide the elements and then we merge the elements. In this way, first I will divide. For this dividing, the time complexity would be O of log base to n. The time complexity would be O of log base to n. And for merging, whenever we are merging the two arrays, the time complexity would be O of n. So whenever I add this O of n plus O of log base to n, so the case would be like the time complexity, the overall time complexity would be O of n log n. So the time complexity of merge sort is, O of n log n. Guys, if you are not understanding this time complexity, you can go and watch my video where I have explained perfectly all about the time complexities, how the time complexity can be calculated. And whenever we are dividing any array, whenever we are dividing something, then that would take the time complexity of log base to n, remember. And why is this O of n take, why is this O of n? Whenever I want to merge, I'll just traverse to the entire array. If the array size is 3, I would traverse till 3. That time complexity would be O of 3. Whenever the array size would be 5, I would traverse till the till the fourth index. So the size of the array would be O of 4. So that's the reason I have taken O of n, and the log base to n is the O of log base to n we will take whenever we are splitting the array or splitting something into two equal halves. So this is the overall time complexity of merge sort. So that's all for today, guys. This was the video for merge sort. I hope you guys have understood the technique of merge sort. If you like the way I explain the video, if you like the way I explain the concept, please like, share, subscribe, and hit the bell icon and share with your friends so that this video would be helpful to all who want to learn the new sorting techniques. So previous video I had explained about the selection sort. In this video I have explained about the merge sort. In the upcoming videos I will be explaining the quick sort and the bubble sort as well. That is very basic. So this was all about the sorting techniques. These 4 sorting techniques you guys have to know if you want to crack any of the interviews, because we don't know, any of the interviewer might ask this sorting techniques, and you guys have to be in a position to give him all these explanations so that he would be impressed at the end. So thank you all. Bye bye. Have a nice day.